Structures. What you're going to write kind of at the top is that we are specifically now thinking about covalent or molecular compounds. Okay, covalent, molecular compounds. All right. So molecular is really the standard. That's what you should be saying. But when you're first learning chemistry, we always like to, call it by what kind of bond it is, which is covalent, right? So real quick, on your periodic table, what side are we now thinking about and looking at? Because we were looking at both sides. Now we're looking at right or the left? The right, exactly. So we're kind of thinking over in this area because our covalent compounds are made up of nonmetals, right? All right. So your Lewis structures, that's the general term that we use for this. They're just electron dot notation for covalent compounds. They are made up of 3 different parts. So we have our atomic symbol, which represents our elements that are present. Okay, so this is still electron dot notation that we're dealing with, right? How do we know how many dots we're putting on our diagram? Valence electrons, yep. So valence electrons, which we're getting from the top of our periodic table, the A's, right? So, and remember when you're putting them around your little symbol, just like, I don't know, phosphorus, something like phosphorus, we have 5. It's in group 15, so we go 1, 2, 3, 4, 5. Okay? So you always start with that first, just like we did in the ionic, or the electron transfer part. Okay? All right. Then we're going to have dots, dot pairs or dashes between these 2 elements, and they represent the bonded electron pairs, or electron pair. In your final answer, you're going to use a line to represent the shared pair of electrons. Okay, so sharing is what's happening now. So in ionic, we were transferring an electron. Now we're going to share. Okay? Each single line represents 2 electrons. Each single line represents 2 electrons. So, for example, if we were to draw chlorine, okay, so 1, 2, 3, 4, 5, 6, 7, because he's in group 17. If I were to have that and then attach it to, let's just go ahead and say another chlorine. I'm just going to do it that way. Sorry. I would put another line here. 2, 3, 4, 5, 6, 7. Now, if you notice, did I follow the same way that I was writing them earlier? No. And you guys, in this chapter, you're going to start rotating them a little bit. You want the single electrons to kind of conveniently be on the same side. Okay? So what this allows me to do is we have a single electron. We have a single electron. I'm going to put a line in between them. If I had drawn this a little bit better, they would have been a little more flat like that one. All right? That's what I kind of meant. So we now have 2 chlorines bonded together with a line. And how many electrons does that line represent? 2. 2 electrons, right? And so what this now shows is chlorine is going to have 1, 2, 3, 4, 5, 6, 7, 8. This chlorine is going to have 1, 2, 3, 4, 5, 6, 7, 8. So everybody now has that stable outer shell. So a shared electron counts for both of them. Okay, hopefully that makes sense. Dots that are only attached to one of your symbols are going to represent unshared electrons. Okay, unshared electron. Your unshared pair is also known as also called the lone pair. Are electrons not involved in bonding and belong only to one atom. Okay, so an unshared or a lone pair are these guys, the ones that we drew initially with our Lewis dot diagram, right? So Just draw yourself a little arrow pointing out that that's the unshared pair. The shared one, or the bond, was represented by a line in between the two. Okay? All right. So this next part I'm going to go through fairly quickly just because, I just want you to know they exist. And you'll start using them a little bit more tomorrow when we actually have the time to practice these a little bit more. But the different types of covalent bonds that we're going to be dealing with, okay? We're going to have single bonds, which is only one pair of electrons being shared. Pair, again, means two. Between atoms, it's represented by one line. A double bond is two pairs, represented by two lines. And then a triple bond is going to be the sharing of three pairs, represented by three lines, right? So just to kind of give you an image of what this looks like, right? So let's go back up to the first one. Single bond, only one pair of shared electrons. So just like what we had up here, but I'm going to go ahead and draw out hydrogen bonded to another hydrogen. So single bond. There you go. A double bond had two pairs. So your most common elements that form these double bonds are ones that have two single electrons. Any guess on what group has two single electrons? Yeah. Nope. Stay away from metals. Non-metals. Yeah. Nope. Not that one either. Think about it.
6A.
You want 6. Yeah. So we want anybody from group 16, right? So that would be the oxygen family. So oxygen is a common one. Sulfur. We're going to add carbon to it, even though it's in group 14, but that's just because carbon tends to single bond, double bond, triple bond, whatever bond it wants, okay? So an example of what this one will look like, so I'll go ahead and show a diatomic oxygen. So we'll go ahead and have an oxygen with two lines connected to another oxygen. So looking, if we're only focusing on one of these oxygens, how many electrons does this oxygen have so far? Not 2. 4. Has 1, 2. Remember, each of these lines represents 2. 1, 2, 3, 4. So how many more does it need? Needs 4 more electrons, right? So the way that it's going to end up looking is we're going to have 1, 2, 1, 2. So we have 2 lone pairs basically going on. Lone pair, lone pair. And then we're going to have the same thing for the other side, right? So this is not me teaching you how to draw these, by the way. I'm not doing that today. This is me showing you what a double bond looks like, okay? So it's okay if it's going over your head and you're like, well, how did you know to like turn things and whatever? You'll get it, I promise. It starts though with drawing these. You're going to connect your dots and you'll see where it'll look prettier by turning them, okay? So I guarantee for your first practice page, you're going to want to just draw them, connect your dots, and then turn them a little bit nicer and redraw them, okay? So anyway, that's our double bond. And then finally, our triple bond is 3 dashes. So if group 16 had double bonds, which group do you think is going to have triple bonds? 15, exactly. So something like nitrogen and phosphorus. Those are your common ones. Okay, so for example, we would have nitrogen, 1, 2, 3, connected to a nitrogen. If we only analyze one of them, we only have 1, 2, 3, 4, 5, 6. There's 7, 8. This side, 1, 2, 3, 4, 5, 6, 7, 8. And that's your Lewis structure. Okay? And we will be focusing on the different shapes as well. But definitely not today.